So we're taking notes on 1.3 using the midpoint and distance formulas. So we get two great definitions here and then our two formulas. Both formulas we should have seen before. I know we've seen distance formula before. I hope you've seen the Pythagorean theorem before. I hope you've seen the midpoint formula before. So if you haven't, those might be new formulas for you. They're definitely formulas that you want to memorize. Our definitions to memorize. We have midpoint, a point that divides a segment into two congruent segments. Congruent segments from last section. So here we're using our congruent segments to build another definition for a point. What do you call a point? That point that's dividing one segment into two congruent segments, you call it the midpoint. If you look at your reason sheet, you see that we get two if-then statements from this definition. If a point is a midpoint, then it divides a segment into two congruent segments. And if a point divides a segment into two congruent segments, then it is a midpoint. You are going to be using both directions of this definition. So we need to know that both of those if-thens exist. Our midpoint formula. The midpoint of 2 points means we have to have 2 points in the coordinate plane. So let's call them A and B. They come in XY pairs. So if A is the first one, it's X1, Y1. B is the second one, so it's going to be X2, Y2. The midpoint. The formula, most people think of it as you get the midpoint. The x coordinate is x1 plus x2 divided by 2, and the y coordinate is y1 plus y2 divided by 2. But we got a third point there. So the midpoint, usually given by the letter M, is another x3, y3. It's another xy point, and since we already have a first point A and a second point B, M, the midpoint, is going to be the third point in our picture. And so, how do you get x3? You add the x's together and divide by 2. How do you get y3? You add the y's together and divide by 2. And you'll see why I use this notation in our example. A segment bisector is a point, line, ray, segment, or plane that intersects a segment at its midpoint. So, segment bisector is interesting because it is the only definition where we use more than two if-then statements. So we're also going to use this as it divides a segment into two congruent segments. More often than not, we're going to use the it divides the segment into two congruent segments. If a point, line, ray, segment, or plane is a segment bisector, then it divides the segment into two congruent segments. So when you look at your reason sheet, you're going to notice that I did not put all 5 of the things in there. Point, line, ray, segment, or plane. You have to know that you can interchangeably use any one of those words. You're never going to use more than one of those words at a time, depending on which of those 5 things intersected at the midpoint or divide the segment into two congruent segments. That's the word you're going to choose to use. So that's important to know there. Very interesting what goes on there with the definition of segment bisector. The distance formula, once again, is the square root of the difference of the x's squared plus the differences of the y's squared. If you don't have that memorized, make sure you memorize it. We use it all year long. The people that get to the final and are shocked the distance formula is on there, I don't know what to tell you. We use it all year long. Let's do our examples. Point C is the bisector of BD. Write an equation to find the value of x. So what does it mean for a point to be the bisector of a segment? It means that it divides the segment into two congruent segments. So C is dividing our whole segment, BD, into those two congruent segments, BC and CD. So, looking at our 5 things, what is dividing our segment into... Nope. It's the bisector. We already know it's the bisector. What is it? It's a point. So if a point, we're given that it's the segment bisector, is a segment bisector, abbreviated to seg-bis, then it divides a segment into two congruent segments. Excuse me. What does it mean for BC to be congruent to CD? If two segments are congruent, then they have the same length. So that lastly, we can write the equation 3x minus 2 equals 2x plus 3 by substitution. Geometry is about being able to take whatever you're given, know what it means. So what is the definition of what your givens are? How can you use those definitions to do something? So we used one definition in this case, what it meant for C to be the segment bisector. To get to another definition, what it meant for two segments to be congruent, so that we could substitute and now do our algebra. So part A here in example 1 is the geometry part of our problem. This is why a lot of students don't like geometry. It's not just look at it and start doing something. It's look at it and know something. You have to know the definition of segment bisector. You have to be able to recognize that this statement is telling you to look up the definition of segment bisector. Point C is the bisector of segment BD. So you look up, what does it mean to be a segment bisector? Oh, now that I have that definition, I can use it to say what the definition lets us say, that the two segments are congruent. I can use the definition of congruent to say another thing before I can do any algebra whatsoever. Geometry is about the thought process, which leads to irritation because generally we like to slap something together and say, ha, I got X, yay, that's good enough. Not in geometry, it's not. So tough it out, you'll be fine. It was writing 2 more steps down. Solve the equation for x. Write our reasons for each step. Okay, so we're going to get our x's together. So subtracting the smallest x, the 2x. 3x minus 2x is 1x by the subtraction property of equality. Getting our constants on the same side, adding 2 to both sides. 1x is the same as x. 3 plus 2 is 5 by the addition property of equality. And we already have 1x equals 5, x equals 5, so we're done. There's our solution for x. Find the length of BC and CD. Are these segments congruent? So BC is 3x. We're going to substitute in the 5 minus 2. So 15 minus 2 is 13. we're going to go to the other one, CD, which is 2x plus 3. Substituting what we know, x equals 5. 2 times 5 is 10. And 10 plus 3 is 13. We substituted and simplified a couple times. What's another name for point C? For a point that divides a segment into two congruent segments? The midpoint. Yes, these are congruent segments. We should know that from point C is the bisector of segment BD. But we also get to know it down here because if two segments have the same length, then they are congruent. And BC is equal to CD. Example 2, the midpoint of segment JK is M, 3, 4. Endpoint J is at 1, 6. Use the midpoint formula to find the coordinates of the other endpoint K. Alright, they gave us coordinates, let's plot them. So we have our x, y axes. The midpoint is the point 1, 2, 3, 1, 2, 3, 4. There's our point M. The endpoint J is the point 1, 6. So 1, 6. There's our point J. What are we looking for? We're looking for the other endpoint over here. Okay. So we're not looking for the midpoint in between J and M. We're looking for the other endpoint of our segment, JK. So this is where, using our formula, as we know the endpoints are x1, y1 and x2, y2. We know the midpoint is x3, y3. We can find x3 because we know it's x1 plus x2 divided by 2. x3 being the midpoint is 3. x1 being the coordinate of x for J is 1. We're looking for the x coordinate of K. Now we have an equation to solve. Multiplying both sides by 2. And subtracting the 1. We need both points, both coordinates of K, the x coordinate and the y coordinate. So we know that y3 is y1 plus y2 over 2. y3 is the y coordinate of the midpoint. y1 is the y coordinate of J. y2 is the one we're looking for. And we can solve, multiplying by 2 and subtracting the 6. We have our end point, K, is the point 5, 2. Notice that when I use a formula, I write the formula down. I'm using my midpoint formula here. I want you to know, whoever is reading this, what formula I'm using. So when you use a formula, you always, always, always write that formula down. Never jump straight into the substitution into the formula. Alright, we get something super fun here. We're going to prove the distance formula given the Pythagorean theorem. So if we know a right triangle, then the sum of the square of the legs equals the square of the hypotenuse. Most people remember that as a squared plus b squared equals c squared. If we have a right triangle where the legs are a and b and the hypotenuse is c, then the sum of the squares of the legs is the square of the hypotenuse. A squared plus b squared equals c squared. So, to prove this, we have to put a triangle on the coordinate plane. So we are going to pick 3 points. 1, 2, 3 points. I'm going to call them point A, point B, and point C. Using capital letters here for the points gives us a triangle. We know it's a right triangle because the way we positioned it here uses the x-axis and the y-axis as 2 of the sides, and we know that the x-axis and the y-axis are perpendicular, form a right angle. So opposite the capital A, we're going to call that side length, the horizontal side, has side length A. Opposite the big capital B vertex point, we're going to name that length, the vertical length, B, using a small b. And opposite the C, the hypotenuse side, we're going to call that small c. Alright, so now we have some lengths which play into our given a squared plus b squared equals c squared. What do we know about the points A, B, and C? Well, we know that A is going to be some x1, y1. And B is going to be some x2, y2. C is on the x-axis at the same place as A. So it has an x-coordinate that's the same. Its x-coordinate is going to be x1. Whereas its y-coordinate is the same as B's y-coordinate. It's y2. So you don't have a new x and y there. You have the same x and y there. So everybody's good there. We're going to now find the distance A in the coordinate plane using the x's. So we're going to say our A, by the ruler postulate, has to be the difference of the x's. So x2 minus x1. Which means our B, using the ruler postulate again, but this time in the vertical direction, is going to be y2 minus y1. We, of course, have to take the absolute values to ensure that those are positive numbers. And now we're going to substitute in. So let's replace A in our given with what we now know A equals as x2 and x1. So we are keeping the rest of the equation the same, so c squared. We're just changing the A into what we now know the A equals x2 minus x1 squared. Plus, keeping everything else the same means we keep the B the same. Oh, I didn't write down my reasons. This is the ruler postulate. This is the ruler postulate. And we finally got to our substitution step. So now we're going to substitute again, but this time we're going to substitute the B. We're not substituting into the given, we're substituting into the line that we just made. So keeping everything in that line the same, except for the B, which we're replacing with what we know the B equals. All right. So we have c squared equals the absolute value of x2 minus x1 squared. So the absolute value is there to make sure we have a positive distance. But what happens when we square something, especially a negative number? If we wound up with a negative distance and then squared it, wouldn't a negative times a negative be a positive anyways? So it turns out we don't need the absolute values. We're going to simplify them because we're squaring, and we know that the square will make it a positive anyways. We're going to change the absolute values into parentheses. And lastly, we are going to take the square root of both sides of our equation so that we can get, instead of c squared, just c. When we take the square root of both sides of our equation, we do have to remember that we get both a positive side of that and a negative side of that. But instead of c squared, we just have c. And c is the length of that side. Since it's a length, we know it has to be positive. And there's our distance formula. The distance between 2 points proven with the Pythagorean theorem. As long as the Pythagorean theorem is true, then we know that this is actually the way to calculate the distance in the coordinate plane. Try the checkpoints, write down any questions you have, and I will see you later.